to transport endogenously synthesized triglyceride to the extrahepatic tissue. So again, here, the metabolism of VLDL and LDL is connected together. So when I talk about VLDL, immediately I will talk about VLDL and LDL again. Actually, VLDL immediately about LDL. VLDL transport triglyceride and cholesterol from liver to extrahepatic tissue is the function. Triglyceride and cholesterol incorporated into the VLDL. They are derived from de novo synthesis. The first part, Jafar, de novo synthesis, and the second part from degradation of chylomicron remnant. Okay. Again, like chylomicron, when we are synthesized VLDL, we synthesis as a form of nascent VLDL. Nascent VLDL just has an ApoB100, and again, like chylomicron, receive ApoC2 and E from HDL. So it's acquired ApoC2 and E from HDL. Lipoprotein lipase has a low affinity for LDL, actually, IDL. So hepatic lipase affect IDL and convert it to the LDL. What is that? We will learn. Here you can see, from liver, we synthesize nascent VLDL, contain ApoB100, and receive ApoC2 and E from HDL. The nascent VLDL become mature VLDL. Lipoprotein lipase receive fatty acid, okay, from VLDL and give it to the extrahepatic tissue like muscle, heart, adipose, other tissue. Then what is remain for us known as a remnant VLDL or VLDL remnant. Other name is IDL, intermediate density lipoprotein. VLDL remnant or IDL, doesn't matter, they are same. Like chylomicron again, it's give back opposite to HDL. Okay? And IDL has a two fate. Okay? Here is not actually shown very well, but in the next slide again I will repeat that. In the extra site of hepatic cell, we have an enzyme which is known as a hepatic lipase. Hepatic lipase digests IDL, receives some triglyceride, and also the amount of cholesterol is increased. So convert IDL to the LDL. Convert IDL to the LDL. It's one fate. And the second fate of IDL is uptaken by liver. So IDL has a two fate, two pathway. One uptaken by liver, maybe near to 60 to 70%. 25% is by hepatic lipase convert to the LDL. So which enzyme is responsible for LDL production? Hepatic lipase. From what? IDL or VLDL, doesn't matter. If they give you IDL, you cannot. So the source of production of chylomicron is intestine. The source of production of VLDL is liver. The source of production of LDL is
IDL.
VLDL or IDL, exactly. VLDL or IDL. It's not intestine, it's not liver. It's in blood circulation from VLDL or IDL. So IDL convert to the, actually transfer to the liver or convert to the LDL. Then this LDL just has an ApoB100, okay? Just has a B100. If hepatic lipase actually converted to LDL, ApoE also is uptaken by HDL. This LDL receptor, this LDL particle, again has a two pathway, two fate. One of them is going to the extrahepatic tissue, to heart, to muscle, other tissue, all the tissue, steroid hormone tissue synthesis. And one part is uptaken by liver and through LDL receptor, which bind to the ApoB100. But most part of LDL go to the extrahepatic tissue. What is the function of LDL? Transporting cholesterol to the extrahepatic tissue. Why we call it is a bad cholesterol? Because cholesterol is low. Because it's increased the amount of cholesterol in liver. Extrahepatic, especially in their artery, okay? And these cholesterol lead to the blood occlusion, okay? So again, I have 2 or 3 slides to talk about VLDL metabolism. Here you can see, from liver, we synthesize VLDL. VLDL, by lipoprotein lipids, give fatty acid to extrahepatic and convert to the IDL. IDL has a two fate. One uptaken by liver through LDL receptor, ApoB. The second by hepatic lipase, convert to the LDL. LDL itself has a two fate. One, go back to the liver, then second go to the extrahepatic tissue. And here can be observed through 2 different mechanisms. One is non-specific uptake, and the second is a specific receptor uptake. But it's similar, doesn't matter, just it's related to the uptake. Again, here you can see, from liver, we produce VLDL, nascent VLDL, receive ApoC2 and E from HDL, then by lipoprotein lipase, lose its fatty acid triglyceride, produce IDL. IDL can be uptaken by liver, can be actually converted to the LDL. LDL has a true fate, go to extrahepatic or go to the liver.
When this IDL goes to the liver, what happens then to it?
Again, digest and can be stored and can be synthesized as a form of VLDL again.
Oh.
It's all the time is that. It's dependent on the situation, condition, and hormonal level.
So IDL to be converted into LDL, it needs the hepatic lipase.
Yes, exactly.
If IDL, can it be like directly stored in the liver?
No. None of them cannot directly store. They should be digested when they receive by any actually tissue, liver, extrahepatic. First of all, they digest to their component, then that tissue decide to reassemble them or use them as a source of energy.
Then doesn't that mean all IDL becomes LDL?
Not exactly.
Then the IDL which isn't
Because
converted.
some part of this IDL contain triglyceride fatty acid. This fatty acid in the liver just produce energy, convert to the acetic.
Okay.
For this reason, we can't say all of them is converted. Here is another figure for these together. First of all, when you look at the slide, it's so difficult. But when you actually follow my point and actually different slide, you can completely find out what's happened here. Can you explain it, Jafar? Or you? Yes.
I'll try.
You have to start from here.
So fatty acids, they become nascent VDL, and they have.
Let's me to zoom in.
They become nascent VDL by attachment of apoprotein B100 and ApoE and ApoC.
ApoE and ApoC are received from
HDL.
HDL. And then what happens is that it has 3 pathways, it seems.
No, it gets to connect with the lipoprotein lipase.
Here it either becomes, either loses its fatty acids and becomes IDL, or and it gives off glycerol.
Glycerol is another actually product of digestion of triglyceride. Triglyceride contain fatty acid and glycerol. Glycerol is actually go back to the liver. You don't actually look at the glycerol.
And then this IDL becomes
Has a 2 pathway. Okay, one of them by
one of them goes directly back to the liver.
yes, exactly.
And one
OPO receptor, and then the second by
and the second one becomes LDL.
by enzyme now.
Hepatic
Hepatic
lipase.
Hepatic lipase, exactly. And this LDL can
It can either go back to the liver or go to the extrahepatic tissue.
exactly. So it's actually the whole idea behind the VLDL and LDL metabolism together. But what do you think? Why we need LDL? Because it's dangerous.
So that we
For energy.
convert it back to we can take VLDL out of it again instead of having to throw it away and not use it.
No, my question is, when LDL is dangerous, why we should send LDL to extrahepatic tissue?
To get rid of it.
So that it's converted, like we can convert it back to VLDL and then
Does it
fatty
act?
acids again. And
Does it act as a hormone?
Plasma membrane, vitamin D, steroid hormones, bile acids.
If you just look at this, then most of the time when I ask a question, the answer is in the slide.
But that's cheating, so we
Yes.
we don't.
No,
So you play down.
So it works as a hormone.
because we need cholesterol for different purposes. Okay? All actually kind of cell, they need cholesterol. And some specific type of cell needs more cholesterol. Especially cholesterol, as you know, is a part of cell membrane, plasma membrane. So all of the cells, they need cholesterol for synthesis cell membrane. Again, for synthesis vitamin D, for synthesis bile acid, for synthesis hormone, steroidal hormone, we need cholesterol. So we should provide cholesterol for these cells and tissue. We cannot say because LDL is dangerous, we do not produce LDL and we do not send cholesterol to extrahepatic tissue. So, why cholesterol, actually LDL is dangerous and is important for us? Because near to 70% of cholesterol amount in plasma is in LDL. Okay? And most of these go to the extrahepatic tissue. As you learned till here, LDL is the end product of VLDL metabolism and LDL deliver cholesterol to extrahepatic. How are you? Well, welcome.
Thank you.
You know, in a real situation, I don't allow any student come to the class. LDL deliver cholesterol to extrahepatic tissue. You are new student. I didn't see you. What was your name? Murtaza? You are new student. In the previous semester, you in my classes. No. You changed your face, everything, or not? So I can't remember you. What's going on here, Sadika? What are you doing? You have a problem with yourself? Please someone help me out. LDL can be uptaken through these 2 receptors. One of them known as the LDL receptor mediated endocytosis, which is responsible for receiving 75% of cholesterol, and actually all kind of nucleated cells, they contain LDL receptor. And we have another receptor which is known as a scavenger receptor. You know what is the meaning of a scavenger?
Searches.
Scavenger
Searches
means
for-
takes leftovers.
Exactly. Okay. They actually known as a scavenger receptor. We have different
Travelers.
kind of scavenger receptor or SR, SR A, B, and others. Here we have SRB1. In actually for LDL we have SRA1. For HDL we have B1. These scavenger receptors are located on macrophage surface. Okay, and they have a low affinity actually for cholesterol, but they are located on macrophages, low affinity for LDL, but unfortunately they have a high affinity for oxidase LDL. And oxidase LDL is the main responsible for, okay? So in the next slide, I will show you how atherosclerosis is active.
So oxidized LDL is bad.
So dangerous. Here is a process of endocytosis of cholesterol. But just look at here. We have actually receptor-coated receptor, which is known as a clathrin receptors. Here you can see there is an LDL receptor. LDL receptor. This LDL receptor actually receive cholesterol, receive LDL, coated, and then they go to the, actually they form endosome. There is a some pump here, they decrease the pH, and finally this endosome produce actually lysosome. And lysosome digests this LDL inside the cell to different components, to the actually fatty acid, to the cholesterol. What's happened for this cholesterol? Here again, you can see this slide is better, but unfortunately today we have a problem with the quality of the projector. Again, you can see there is an LDL receptor. They come inside to the cell. Then, when they produce endosome, the LDL receptor leaves and go back to the cell surface. Then this cholesterol is digested in lysosome. Protein convert to the amino acid, triglyceride to the fatty acid and glycerol, and cholesterol here. What's happened for cholesterol? Cholesterol can be actually converted to the ester cholesterol by adding acyl or fatty acid. The enzyme here known as acyl cholesterol acyl transferase. Acyl cholesterol acyl transferase. And then they can esterase inside cells. ACAT. Okay. Here also there is some actually gene for producing receptor which they lead to the location of the receptor on cell surface. In addition to exogenous cholesterol from LDL, also we can synthesize cholesterol from other components. Okay, we will learn it tomorrow how cholesterol is synthesized in our body. But when the cholesterol amount is too much, this amount of cholesterol inhibits this enzyme, which is the main enzyme in cholesterol synthesis, and also inhibit the gene for synthesis of cholesterol receptor. So when the cholesterol amount is high, they lead to the actually inhibit the LDL cholesterol receptor synthesis. What's happened after that? When we don't have LDL cholesterol here, the LDL in the plasma cannot enter to the cells. They increase in the blood circulation. And when they increase in the blood circulation, they go to the behind the cell wall and produce a foam cell and lead to the atherosclerosis. So let's to see here what's happening. Different kind of heart disease, heart attack, stroke, and actually we call it cardiovascular disease or CVD. Cardiovascular disease or CVD or atherosclerosis, they can be occurs due to the LDL. But related to LDL, one point is so important is the size of LDL. If the size of LDL be large is dangerous or be a small?
Large.
Large, exactly not. Be a small is so dangerous. Why?
Because it comes up faster.
No, because you know, they are the cell wall, okay? Cell wall of blood artery.
Can
okay?
enter faster.
They can.
Then this cholesterol should entrance through this cell wall to the layer behind the cell wall of blood artery. If the size be small, they can enter easily. Okay? So the biggest problem related to LDL is the size of LDL particle. When the size of LDL particle be small, is more dangerous than those with large size. What's happened exactly? Here in the slide you can see what's happening. Let's need to focus on it, maybe it's somehow clear.
So the oxidized LDL is smaller. Should be.
Exactly. Here you can see how oxidized LDL is created. Different factors, different enzymes, different situations, they lead to the increasing oxidized LDL. For example, different oxidant, hydrogen peroxide, nitric oxide, superoxide, all of them, any kind of oxidative stress lead to the increasing oxidized LDL. If you're living with a higher stress lead to the oxidative stress lead to the oxidative LDL increase. So stress is so dangerous for patient with heart disease because it's increased the oxidized LDL also. And we can actually somehow decrease the amount of oxidized LDL. By what? By this kind of diet. Vitamin E, ascorbic acid or vitamin C, beta carotene or vitamin A, D, and other antioxidant from diet. If you use antioxidant, okay, they can help you to reduce the oxidase LDL. So they are macrophages, okay. Then they are the actually the endothelium of the capillary, okay. When there is actually problem here, for example, the blood pressure is so high. Those people have a high blood pressure. This blood pressure actually leads to this space between these cells increased. Then these macrophages or monocytes can leave the blood circulation, go to the behind the cell wall. Yeah. Here also we have actually oxidized LDL. Then these macrophages start to eat this oxidized LDL. Okay? Because this oxidized LDL act like a xenobiotic. You know what is the biotic? Those extra actually material which come from the environment to our body, and our body detect them as an invasion.
Parasite.
Okay? For this reason, attack them and eat them. So, when macrophages eat this oxidase LDL, the size of macrophages is increased. And they become these kind of cells which known as a
Foam cell?
foam cell. Exactly. These foam cells, they can connect, they can join together and produce a complex of these foam cells. Then the artery epithelium, endothelium, is actually, for example, imagine this is the artery, you know, and from here the macrophages increase this size. Okay? Finally, this volume, this size completely is stopped, is actually clotted. Then, if it's happened in our heart or our brain, lead to the stroke? Actually, arteriosclerosis. So you will learn a lot in the next semester related to arteriosclerosis, especially in the heart and actually liver. But here, just imagine how it can be actually active.
So it doesn't count it as waste and gets rid of the LDL or no?
What?
The macrophage, it doesn't get rid of it.
They doesn't get what?
Rid of the LDL, oxygenized.
No, they can reduce actually LDL. When they actually start to eat the oxidized LDL, they lose their activity. They become like a space just can eat and increase the size, you know. If somehow at the beginning, actually they can actually digest these oxidized LDL and be active. But after many times, when they receive a lot of the oxidized LDL, they lose their activation. They are activated and then they become just a space for eating a lot of cholesterol and becoming a foam cell.
Complex.
There are a lot of actually YouTube video related to atherosclerosis. If you just search on YouTube on atherosclerosis, you can see a lot of animation and clip which very, very good show you how these oxidized LDL finally lead to the atherosclerotic plaque. We call it the atherosclerotic plaque. These foam cells together, they create a plaque. And this plaque may be here in this actually position lead to the blood occlusion, may be moved to blood circulation and went to those capillary which they are so tiny and lead to the occlusion there, especially in the heart. So and then it was LDL. Final part of lipoprotein metabolism is related to HDL metabolism. Till now, you learned what is the function of chylomicron, VLDL, and LDL. What is the function of HDL? The function of HDL.
It provides the ApoC.
One of them is providing ApoC2 and ApoE for other chylomicron and lipid metabolism. Is the one of the main function. Then the second and the main function, the first actually.
Activation of lipo.
Transport the cholesterol from adipose tissue to liver.
From extrahepatic, it's better say from extrahepatic to the hepatic, to the liver. Is the main function of HDL. For this reason, we call it a good cholesterol, because it's decreased the amount of cholesterol from extrahepatic and converted to the liver, transported into the liver. So, related to HDL, both intestine and liver can synthesize HDL, both of them, intestine and liver. The first HDL which is synthesized, again known as a nascent HDL, or other name is disc-like HDL or discoidal, because it's like a disc, okay? Discoidal HDL. There are two main functions of HDL: transfer of protein or other protein, and reverse cholesterol transport. We call it reverse cholesterol transport from extrahepatic to the liver. So, what is the main function of cholesterol? Is obtaining HDL, obtaining cholesterol from extrahepatic, give it to the liver. But it's so important how much this cholesterol is active and how much can transfer this cholesterol to the liver. Can you imagine for VLDL and chylomicron what's happened after lipoprotein lipase digest them? They become remnant, and this remnant they are going to the liver. So what's happened here? Cholesterol, HDL actually, when received cholesterol from extrahepatic in the blood circulation, he think with himself, VLDL remnant or IDL actually, or chylomicron remnant, they are going to the liver. Let's give them some cholesterol. They carry cholesterol for me, okay? And also, when the amount of cholesterol in HDL is increased, they should be uptake by liver. For this reason, for being more activate, HDL gives its cholesterol to the chylomicron remnant or IDL or VLDL remnant, and its cholesterol content decrease, so again it can receive another cholesterol from extrahepatic tissue. By which factors can you give me?
ApoB, ApoC.
No ApoC?
Apo
No.
A1?
D. Cholesterol ester transfer protein, CETP, I told you. This is so important. CETP, cholesterol ester transfer protein. So let's look at that, what's happening. First, uptake cholesterol by HDL. HDL receive cholesterol from other tissue. If actually, here we have a receptor which known as an ABCA1, ATP binding cassette transporter A1, okay? And this is lead to the transporting cholesterol from extrahepatic to the HDL. If we have a problem in ABCA1, lead to the disease which known as a Tangier disease. This Tangier disease, the HDL content is so low, okay? HDL cannot receive cholesterol. Then this cholesterol, when it received from the extrahepatic, inside the HDL, it should be esterified. It should be esterified. What is the meaning of esterification? Adding fatty acid. So, in the plasma cell membrane of all of the cell, we have a free cholesterol. This free cholesterol should uptake, then we have to add a fatty acid and then transport it to the HDL. This process known as esterification of HDL cholesterol. So, from what site, from what molecule we receive this fatty acid? From phospholipids. Which one is important in the cell membrane? Lecithin. Lecithin is the highest amount of phospholipid in the cell membrane. So we have an enzyme which known as an LCAT. It's so important enzyme in metabolism of HDL. It's known as a lecithin cholesterol esterase. What's the meaning of that? It means receive fatty acid from lecithin, adding to the cholesterol, produce ester cholesterol. What remains from lecithin when we receive a fatty acid? When phospholipid actually lose one fatty acid, they produce
monoglycerol. Two monoglycerol.
two monophospholipid.
No, two monoglycerol.
Yes.
No. In the previous semester also, I told you. Lysophospholipid. Lysolecithin, okay? Lysolecithin. Lecithin which is lys, just that. Lysolecithin. So, LCAT, for its activity, needed what? I told you at the beginning of the class.
A1.
A1. ApoA1 was so important for LCAT. So LCAT is stimulated by ApoA1. Is the function of A1. For example, for this reason, A1 is the main apoprotein in HDL. Because A1 is important for activation of LCAT, and LCAT is important for esterification of fatty acid, cholesterol, and for receiving cholesterol from the extrahepatic tissue.
So ApoA1 is stimulates LCAT to cut the fatty acid.
Exactly. Without A1, this enzyme cannot do that.
So A1 just stimulates. It's not the one that actually cuts.
LCAT do that. LCAT is an enzyme. Yeah, but A1 is necessary for activation of LCAT.
Actually stimulates.
And as you learned, the transfer of cholesterol ester from HDL to the lipoprotein remnant, by CETP, cholesterol ester transfer protein. Here you can see what's happening. As I mentioned, because this protein, LDL, remnant, LDL, and chylomicron, they are going to the liver, HDL, give them cholesterol ester and receive triglyceride. Give cholesterol ester, receive triglyceride, and decrease its amount cholesterol and give them the cholesterol. So by this action, transport cholesterol to the liver, and again it remain active and can do a lot of these reverse transport cholesterol. It's amazing when you actually find out the action. For this reason, one of the most important protein the cardiologists are actually focused on them, those people actually work on cardiovascular disease, is CETP. They say if we increase the amount of CETP, we can decrease the amount of cholesterol and also help HDL to be active more and decrease the risk of atherosclerosis by increasing the CETP. So a lot of study on cardiovascular disease this time are focused on CETP. Here again you can see, and also in the next slide, HDL can be synthesized from liver, from small intestine, which is known as a discoidal or nascent HDL, which just contain ApoA1. Yes?
When I gave the cholesterol to LDL, why LDL go to liver and no return to the body?
Not LDL, to the ideal or chylomicron remnant,
yes,
or VLDL remnant, yes. And also LDL, some part of LDL also go to the liver. It can detect which particle are going to the liver, just give them the cholesterol, okay? Not for LDL which go to the extrahepatic. It's give cholesterol to those particles, they are going to the liver just. You got it? So, cholesterol from peripheral tissue is received by LCAT, and actually from phosphatidylcholine, one fatty acid is added and produce cholesterol ester. Then lysophosphatidylcholine is remain here, and LCAT is activated by ApoA1. First of all, we have HDL3. HDL3 has the lowest amount of cholesterol. Then, if it receives a lot of cholesterol again from extrahepatic tissue by LCAT, it's converted to the HDL2. Okay? Then again can receive another actually cholesterol and convert to the HDL1. There are different kind of HDL, and it's so important. And then this HDL can give cholesterol by CETP to the others. Some part of HDL come actually uptake by liver, and some part again remain in the blood circulation active. Finally, all kind of HDL should be uptake by liver and give cholesterol and cholesterol ester to the liver. And this cholesterol in the liver, what is the final result of this cholesterol? It should be converted to the
Energy? TGA?
bile. It should be converted to the bile and then excrete from the bile. So,
Could you repeat this one?
what?
This slide?
Again,
Yes.
HDL can be synthesized by both liver and small intestine as a form of discoidal nascent HDL, just as an ApoA1. Then, from extrahepatic tissue, by LCAT, which activated by A1, and receiving fatty acid from phosphatidylcholine, it produces cholesterol ester inside the HDL. And discoidal nascent convert to the HDL3. If receive more, convert to the HDL2. If receive more, convert to the HDL1. So finally, this HDL 2, 1, or 3, doesn't matter, all of them they can. Some part of their cholesterol convert to the actually VLDL remnant or actually chylomicron remnant. Okay, and by these 2 or 3 particles, they give the cholesterol to the liver. Again, they can be activated when they give the cholesterol amount decrease from HDL2, they again convert to the HDL3. And hepatic lipase also help them somehow in this actually conversion. Finally, this HDL1 should be uptake by liver through the specific receptor which is known as a scavenger receptor B1. And then in the liver, cholesterol removed from HDL and convert to the body. Again here you can see what's happening from intestine and liver. We synthesize nascent HDL. Nascent HDL can receive cholesterol from VLDL, from IDL, from chylomicron remnant and become mature HDL and then finally transport to the liver by SRB.
So the PC, when it turns from lyso-PC, does it come from the VDL and the other ones, or is it in the HDL3?
What do you mean? Phosphatidylcholine just give a fatty acid. Just give a fatty acid.
Where does it come from?
In the blood cell membrane of all of the cell. Phosphatidylcholine present in the cell membrane.
When it gives a fatty acid, it turns into a lyso.
Lysophospholipid.
Okay.
Again, it's like that. Synthesize is freedom. It can receive by LCAT, HDL3, HDL2. Then, when they give a cholesterol by hepatic lipase, they can convert from HDL2 to HDL3. Finally, by SRB1, they cannot take. So, the last part of this slide is related to HDL, and this is related to HDL. We just take actually, when we talk about HDL, all the time we say it should be higher than this amount. Today, maybe we are going to evaluate the HDL cholesterol. Actually, today experiment is related to LDL and HDL measurement. But we do not measure the HDL and LDL themselves. We just measure the amount of cholesterol of HDL and amount of cholesterol of LDL. So we call it LDL cholesterol and HDL cholesterol. So when you ask actually lab to do the experiment of HDL and LDL, you mean evaluate the amount of cholesterol of HDL or LDL, not amount of LDL or HDL itself. So for HDL, if the concentration of HDL cholesterol be less than 40 milligram per deciliter, it means it's low HDL cholesterol and has the highest risk for heart disease for the men. For women, the value is less than 50. Between 40 and 60 is a medium, is a normal HDL level. And more than 60 is a desirable, is a high HDL level, optimal condition, and lowest risk of atherosclerosis.
So the higher is better.
The higher is better. The higher is so better.
Is there, something like too high or no?
Usually no. Usually we don't have actually two. Just is the session number 1.